Hey everyone, we're back, and recently we were looking at how do we determine if a linear term can be considered a factor of a polynomial. And there were two ways that we looked at this. The first was dividing the two. So we would have 2x cubed minus 3x squared minus 5x minus 12, and we would divide that by x minus 3. And from that, we looked at the remainder. We call this long division. Or we use long division to do this. And then the alternative to that, looking at long division with the remainder, is we also saw towards the end of the lesson that if we place k, which would be 3 in this situation, if we place k into this polynomial, do we get 0? And if we do, then that tells us that our term is in fact a factor of this polynomial. So let's recap exactly how we perform long division. So we have our divisor x minus 3, and then our dividend 2x cubed minus 3x squared minus 5x minus 12. So we always pay attention to the leading term. So in this case, we pay attention to the x and initially the 2x cubed. So you think we have to multiply by 2x squared. So that would give us 2x cubed and minus 6x squared. And with long division, one of the things I had mentioned is that we tend to forget, we might forget that we have to subtract each of these groupings. So we do in fact subtract. Our cubes go away. Negative 3 and plus 6 would be positive 3 x squared, and our minus 5x drops down. Next, again, now we pay attention to 3x squared. That would be positive 3x. That would give us 3x squared minus 9x. Subtract, giving us positive 4x. Drop our next term down, and it looks to be that we could multiply by 4x minus 12, and we get 0. So with this remainder, what can be said? We can say that x minus 3, because we divide and get a remainder of 0, we can say that in fact x minus 3 is a factor of the polynomial. Now, in today's lesson, we're going to look at something called synthetic division. And synthetic division is simply an alternate form of dividing. We have this long division with variables, and it's much like how we divide regular numbers. But synthetic division, some would consider to be more cleaner. So this is today's topic, synthetic division. Okay. Now, let's say we're still looking at this situation. 2x cubed minus 3x squared minus 5x minus 12, and we're dividing that polynomial by x minus 3. So how we do this is we first think of x minus 3. If it was a factor, what would its 0 be? So we know we set it equal to 0, and after setting it equal to 0, we would get 3 from that. And we're going to put this in a little box, like that. Okay. So from there, we then take all of the coefficients in our polynomial, or in our dividend. So we would have 2, negative 3, negative 5, and negative 12. And I should say right now, just like long division, the terms have to be in decreasing order. So our highest degree first, followed and ending with our constant. So it has to go in that order still in synthetic division. Alright, so this is actually the setup for synthetic division. And what we do is we drop our first term, so we drop the 2, and we take our 0, our possible 0, write this down, 0 of divisor. We drop that and we multiply it by the 0. So 3 times 2 we know to be 6, and that goes up in the next position. Okay? So now the next situation, we take -3 and we're going to be adding these two together. So much like in long division we were subtracting each line, here we add. That's one difference, we add in each situation. So -3 plus 6 is +3. And we repeat. Our 0, 3 times 3, which is 9. That comes up here. And then we add. -5 plus 9, that would be +4. And then again, repeat. 3 times 4 is 12. We add. And we see that we get 0. Now, what does all this mean? What do all these numbers mean to us? Well, the last number you'll find in this synthetic division process, this will be your remainder. Okay, so this matches to what our long division found. We found that our remainder here was 0. We still find that it is 0. And this grouping, which will be our quotient, these are the coefficients of the quotient. Now, I want to say this. If we started out with a cubic function, and we're dividing by a linear function, so we're taking a polynomial of degree 3 and dividing it by a polynomial of degree 1, what we find is we get a polynomial of degree 2. Now, just in general, just so you know this, whatever our polynomial is, our quotient, our result, will be 1 less degree. So if we had a degree of 7, our result would be a degree of 6, and so on. So what our result looks like is we can take our initial polynomial, 2x cubed minus 3x squared minus 5x minus 12, and say that we can take x minus 3 and multiply that by 2x squared plus 3x plus 4. So again, same thing we found up top, but it's much more condensed and much more cleaner, I guess you could say. But this is synthetic division. So let's practice this a little bit. So I want to remind you, any questions or comments you have, please start putting them into the comment below in the Google Classroom, and we can talk about those situations, those ideas as we go. So let's take the situation. Let's divide x to the power of 4 minus 10x squared minus 2x plus 4. Let's divide this polynomial by x plus 3. Okay, so we could easily set this up as long division, but let's see what it looks like in synthetic. So let's just imagine for a moment that x plus 3 is in fact a factor, so its a 0 would be -3. That goes in a little box. So then we take the coefficients for each term. So our leading coefficient is 1. That's to the power of 4. So we don't have a cubic term, x to the power of 3. So we do have to put a 0 in here for that, since we do not have an x to the power of 3. Then we have a -10, a -2, and a +4. Alright. So I'm going to write this to the side here just for you, and might help us kind of think about this process more. The vertical pattern in this synthetic division, the vertical pattern is addition. the diagonal pattern is multiplying by the possible zero. Okay, so let's try this. So 1, well, nothing's here, so that's why it just drops down. So now we multiply the diagonal, we multiply by our possible zero. So 1 times -3, we get -3. 0 and 3, -3, we get -3, and we just keep repeating this process. -3 times -3, -3 times -1, -3 times 1, okay, so I'm going to ask you, looking at this result, can we say that x plus 3 is a factor of the polynomial? We should think, because we have a remainder that's not 0, this is not a factor. So what we would find as our summary is x to the power of 4 minus 10x squared minus 2x plus 4 will equal, yes, it equals x plus 3 multiplied by, let's see, the power of 4, so this would be 1x cubed minus 3x squared minus x, or 1x, plus 1, but we still have a remainder, so we have to add our 1 there to the end. So this would be our summary statement, I guess you would call it. Now, before we move forward, I want to add this comment, remark here. Synthetic division, in this whole process, one limitation that it has is it can only be utilized for linear divisors. So if we were dividing a polynomial by, say, a quadratic or a cubic function, synthetic division would not work. We would have to use long division in that case, which is why some of you might be asking, why didn't we teach this first? Why didn't we go over this first? It is just because of that. This has a limitation, whereas long division doesn't necessarily have one. It's just more time consuming. Okay? So let's look at another situation. Let's look at this problem. Is x plus 2 a factor of this function? So it's 3x cubed plus 8x squared plus 5x minus 7. And if it is, then write this function as a product of factors. So then write f of x as a product of factors. Okay. So how do we determine if a term, a linear term, is a factor of a polynomial? So we saw previously that we take our possible zeros, which would be -2, we place it into our function, and what we want to find is that it equals 0. So if it does, it is a factor. If it doesn't, then we just stop there. So we place -2 into our function, and after doing this whole calculation, we get -9, which isn't what we were looking for. So since f of -2 does not equal 0, x plus 2 is not a factor of our function. And we just stop there. Because if it's not a factor, then we can't write this as a product of factors. There would be a remainder involved, not just is not what we exactly want. Okay, so I hope we're doing good on this concept. It's rather straightforward, it's just it looks different, and the method behind it is new to us. This whole idea of, vertically adding, diagonally multiplying. Let's look at one more situation. Let's say we have this scenario. So it's going to be a different request. Show that x minus 2 and x plus 3 are factors of f of x. And our function is this polynomial. 2x to the power of 4 plus 7x cubed minus 4x squared minus 27x minus 18. Okay, so we want to show that these are factors. So it's already, we're kind of assuming here that if I were to place, the zeros into the function, that we will get 0. So let's see if we can use synthetic division and go from here. Okay. So let's say let's start with x minus 2. So it's possible 0 would be 2. We place all of our coefficients in. So 2, 7, negative 4, negative 27, and negative 18. Okay. So I encourage you with this problem, since we have gone through 2 of these already, pause the video and see if you can work through the process yourself and replay to see how you did. Okay, so let's see. So we drop the 2. We get 2 times 2, it is 4. Then we get 11. 2 times 11 is 22. Then we get 18. 2 and 18 is 36, which gives us 9. And positive 18, which gives us 0. That's good. That's awesome. So this is a factor. We showed that just now. So what we can say so far as our function is this polynomial can be written as x minus 2 multiplied, since this would be a cubic function, 2x cubed plus 11x squared plus 18x plus 9. Okay. So from here, looking at our next factor, we're going to take this factor, and since we already know that x minus 2 can be found in this, and as a result we get this new polynomial, let's take this factor and see how it is placed into this new polynomial. So we're going to take x plus 3, which gives us a 0 of negative 3, and we're going to utilize this new polynomial we got previously. So that would be 2, 11, 18, and 9. Okay, let's work through this. Drop the 2, get negative 6. Negative 3 and 5 is 15. Negative 3 and 3 is negative 9, which gives us 0. Okay, which is again exactly what we wanted. Now, as a result, our result in this problem is that our initial polynomial can now be written as x minus 2, x plus 3, and then we have this, which went from a cubic, now we have a quadratic. Okay. And believe it or not, we could now check this quadratic to see if it can be factored. Now I know we don't have possible factors to check here, so that's not a big issue. I mean, we know how to factor a quadratic. So I'm going to utilize our chart, so drop 2, 5, and 3. Let's see. So 2 and 1. 1, 3, which would give us 2 and 3, which we get our 5 in the center, which is good. That tells us that we can factor this quadratic as 2x plus 3, and then x plus 1. So this is the complete factorization of our initial polynomial. And if we wanted to, we could easily sketch this graph. We would have 4 zeros, a degree of 4, leading coefficient that's positive, all those things we saw previously to help us graph functions like this, but we don't need to do that right now. What I'm going to have you do to end this lesson, I'm going to have you kind of go through a similar process. So in this last problem, let's say we have, I'm going to ask you to do this. Verify. Verify that the following factors, that x plus 2 and x minus 4 are factors of this polynomial 8x to the power of 4 minus 14x cubed minus 71x squared minus 10x plus 24, and then find the remaining factors of this polynomial. So very similar to what we just saw. So I'm going to encourage you now to go forward with this example. I'm using synthetic division, determine, or to show that these two terms are factors of the polynomial, and then factor what it remains, so that we can write this polynomial as a set of factors. So if I had a degree 4, we should know that we should have 4 factors at the end. So the answer to this problem, to this example, can be found in the notes that I posted with this video. But like I said at the beginning, if you have any questions or concerns or confusions regarding synthetic division and how we use it here, please post a comment, post a question, and we're going to practice and discuss this further in class when we see you again.